Okay, this is part two, and we're continuing on with looking at factors in causation. The term risk factor is commonly used to describe factors that are positively associated with the risk of development of a disease, but that are not sufficient to cause the disease. The concept has proved useful in several practical prevention programs. Some risk factors, such as tobacco smoking, are associated with several diseases, and some diseases, such as coronary heart disease, are associated with several risk factors. Epidemiological studies can measure the relative contribution of each factor to disease occurrence and the corresponding potential reduction in disease from the elimination of each risk factor. However, multi-causality means that the sum of the attributable fractions for each risk factor may be greater than 100%. The effect of two or more causes acting together is often greater than would be expected on the basis of summing the individual effects. This phenomenon is called interaction. It is illustrated by the particularly high risk of lung cancer in people who both smoke and who are exposed to asbestos dust. The risk of lung cancer in this group is much higher than would be indicated by a simple addition of the risks from smoking and exposure to asbestos. Multiple causes and risk factors can be displayed in the form of a hierarchy of causes, where some are the proximal or most immediate causes, and others are distal or indirect causes. Inhaled tobacco smoke is a proximal cause of lung cancer, while low socioeconomic status is a distal cause that is associated with smoking habits and indirectly with lung cancer. In epidemiologic studies linking one or more causes to a health outcome, it is important to consider to what extent different causes are at the same or different levels in a hierarchy. If a cause of a cause is included in the analysis together with the cause itself, the statistical method of analysis has to be taken into account. That's something we're not going to get into. The identification of a hierarchy of causes and the quantitative relationships between them will provide one way of describing the mechanism of causation. For example, low socioeconomic status is associated in many industrialized nations with more tobacco smoking, which is associated with higher blood pressure, which in turn increases the risk of stroke. Causal inference is the term for the process of determining whether observed associations are likely to be causal. The use of guidelines and the making of judgments are involved. The process of judging causation can be difficult and contentious. It has been argued that causal inference should be restricted to the measurement of an effect rather than as a criterion-guided process for deciding whether an effect is present or not. Before an association is assessed for the possibility that it is causal, other explanations such as chance, bias, and confounding have to be excluded. A systematic approach to determining the nature of an association was used by the U.S. Surgeon General to establish that cigarette smoking caused lung cancer. There are a set of considerations for causation listed in the sequence of testing that an epidemiologist should follow to reach a conclusion about a cause of disease. So this table here from the textbook presents considerations for causation. I'm not going to read through these, but if you want to check these out at all, you can go ahead and do so here or within your text. There are no questions on your homework related to this. Study designs and their ability to prove causation. At the top are randomized controlled trials. And then at a moderate level are cohort studies and case control studies. That completes part